have based on the information that we're given and based on the slope, right, or based on the rate of change. So in example, use the table, find the average rate of change over the following intervals. And this is going to help us know, do we have a function? And is it linear? Okay. Now you can already tell if we have a function. Okay, is this a function looking at our x values?
Yes.
Yes. Why?
None of the x's repeated.
Right. There's none repeated in that x column. So we know that it's a function. We just don't know what type it is. Okay? So go ahead and fill in. Remember we did this part yesterday? I gave you the x values. Okay? You just have to pick out the y values that correspond. So when x is 0, what's y? 5. And we can find that right here from the table. Okay, when x is 2, y is -3. Now that we have 2 coordinate points, we can use our slope formula right here to find the slope. Okay, or you could say find the rate of change. So I'm going to go ahead and label just to make sure we're all on the same page. So I'm going to do my y's on top, -3 minus 5, and then on the bottom, my x is 2 minus 0. That will give me -8/2, which is -4. Make sure we're reducing all the way down. If you need to use your calculator to help you, that's okay. Just a reminder, guys, no cell phones, no headphones, where we're doing notes, okay? Okay, our next one. I gave you the x's are 1 and the x's are 4, and the x is 4. Okay? When x is 1, what's y? 1. Get that from our table over here. And when x is 4, y is negative. Bless you. Okay, go ahead and set up the slope formula on your own. So you can do that on your own. Also, -4.
How did you go to your function?
Okay. Did we get -4?
Yes.
All right. From yesterday, you should get -4. Check your work.
Is it
You did it.
-11 minus u minus 2
Y minus 1. Okay. So, from yesterday, if we have a constant slope or the same slope, what does that tell us about our function?
It's linear.
It's linear. It is a straight line. So today, phone away, please. Thank you. All right. So when we're doing these today, if you get the same slope, it's a straight line. If you get different slopes, it's not a straight line. It's really that simple. That's kind of what we're going to be doing today. So is this linear? Yes, it is. Okay, and you can just tell me if we have the same slope. Okay, so if we have the same slope, it's linear. That's really what today is about. Any questions on example 1?
No.
All right, let's go to example 2. All right, now, this is a little different. I'm going to give you the option of using Desmos to help you, because you can do that on a test, you can do that on your OST, okay? So, let me go ahead and pull up Desmos for us. Oops. What's my function there? Is it 3x plus 5?
Yes.
Okay. So if I put that in, y equals 3x plus 5. Okay, I'm going to get a table, and I can fill in the values that I need. Okay, let me make that half screen here. Okay, so if you look at, here we go. Okay, this is going to make it easier for us. Okay, so when x is -1, what's y? 2. Okay, when x is 5, what's y? Well, we don't know yet. Stay with me, please. Okay, when x is 5, we have to find y. We don't have it yet. Just put it in that table. It'll tell you that it's 20. Okay, so you can go ahead and find the slope in part A. Do you agree with my slope in part A?
Yes.
Okay, we should be getting 3. So if we get 3 for the next 2 examples, what does that tell us about this?
It's
It's linear. So let's see if that happens. All right, so 1 corresponds to 8. Okay, we don't have 4 up here yet, so let's put 4 in. 4 corresponds to 17. Okay, you should be getting 3 for that one as well. All right, and letter C, 2 and 3. We don't have 3 up there yet, so let's put 3 up there. Okay, 2 corresponds to 11, and 3 to 14.
Sweet. Linear.
Yes, it should be linear. All 3 slopes were the exact same, so it is linear. Okay, and I want to make sure that we're clear. The reason it is linear is because there is a constant slope. Yes?
Yes.
Yeah.
Okay. Okay, questions, issues, concerns? Okay. All right, tip 3, find the average rate of change for f of x equals x squared plus 2 over the interval -3 to 0. So I have given you the x's. Okay, how are we going to get the y's? Desmos, or you can plug it in and do it by hand. It does not matter to me which way you do it. Since I already have Desmos up, let's make it happen. Okay.
Y equals x squared.
Y equals x squared plus 2. All right, create a table. All right, so we need which values?
0 and -3.
Okay, -3 corresponds to 11, and 0 corresponds to 2. I'll let you go ahead and find the average rate of change. Oh yeah, corresponds to 2. All right, did it get the same answer? Yes. Okay. Now I want to just ask you. We didn't do 2 different rates of change here, but looking at this equation, do you think it's linear?
No.
No.
Sometimes.
No.
Okay, if you say no, raise your hand. Okay, can somebody get in the no clan? Give me a reason why. Why are you saying no?
It's not straight line.
How do you know it's not a straight line? The exponent. Okay, so let's go back to Desmos. Look at that graph. It's not a straight line. But if I look at what was our last one? Y equals 3x plus 5.
Yeah.
Okay, look at that blue line. make this a little bit bigger here. Look at that blue line. That's straight. So if it has an exponent of 1, because that's technically x to the first there, okay, it's going to be linear. But if it has an x squared in it, or an x to the third, or x to the fourth, it's not going to be linear. Okay, so just kind of, I'm sorry?
There was the x squared thing we just did. Isn't that?
Look at the graph.
Oh, I was being upset.
Yeah, so if it has an x squared, it's not going to be linear. That's kind of a quick way you can actually look at it, and you can tell if it's going to be linear, and you can prove it with your slope. Okay. All right, a couple OST questions, and then I'm going to let you work on some practice, and we'll do some retake. Okay, so we have Francine. Okay, Francine creates a bar graph showing the distance between her city and each state capital city in the United States. Which unit of measure would be an appropriate unit for Francine to use to label her graph? Okay, so it's distance between her city and each state capital city. We can bring miles. Do you think anything different?
All 4.
Is that a random question? Is it kind of random? You're like,
Yes.
okay, but think about, we want to use centimeters, inches, maybe kilometers. Okay, you're like run a 5K.
Yeah.
Okay, so sometimes kilometers and miles are kind of our biggest. Definitely miles on that one. Super random question. Sometimes they will be that easy. You're probably thinking, really? Sometimes that happens. Okay. I don't know why they asked us like that, but maybe to check your common sense a little bit. I have no idea. Okay. Michelle holds a small rock in her hand. Okay, density can be found using the formula density equals mass divided by volume. Which unit would be the most appropriate for calculating the density of the rock in Michelle's hand? So does anybody know how we measure mass?
No.
Mass would okay, but I'm saying what unit of measurement is mass in? It could be grams, it could be pounds, it could be kilograms, maybe tons. But let's talk about volume. If you ever have to find the volume of something and label the answer, does anybody know how you always label volume? So squared would be area. Squared would be cubed. Yes, cubed. Okay, so if you look at these, you know that it's going to be this one or it's going to be this one. Okay? Now, you've narrowed it down to knowing that it has to be cubed. Oh, sorry. Or this one. Okay?
Or the other one.
Oh!
Yeah.
What the heck? Okay. Darn it. Never mind. We'll get this. All right. So let's rewind and talk about a rock. If she's putting a rock in her hand, we can assume it's not extremely large, right? Like it's not ridiculously large. So what's going to be out? Okay. What else do you think is going to be out?
Pounds.
Probably pounds. Okay, probably pounds. Now, if it was saying that she was holding a heavy rock, maybe you could assume pounds there. But okay, kilograms and grams. What do you think?
Grams.
Probably grams. Okay, so you just have to use your common sense on that one. All right, go ahead and work on your practice. The solutions are on the back. I'll be around. I'm going to go ahead and pass out some retakes for our friends who need to retake their domain information.